Okay, welcome back everyone. In this video, we're going to be talking about many of the different properties that all waves exhibit. So this includes things like superposition, interference, reflection, refraction, dispersion, and finally diffraction. And so I'm going to introduce these terms now. We're really going to get into them when we start discussing sound, and then later on light. So I'll start with superposition, and believe it or not, you already know what superposition is. Let's say, for example, you have two forces acting on something at the same time, so two forces going that way and that way. Well, we already know how to deal with two forces being in the same place at the same time. We have to add them up, and that is our resultant force. That's another way for talking about superposition, and this happens for waves too. So superposition for waves is two waves in the same place at the same time. And so what do we do to deal with this? Well, we just add the amplitudes. And you'll see a practice page that has to deal with this. So there's different types of superposition that you can have, and in order to try to get some superposition, I'm going to also tell you about interference, which is basically the same thing. Interference, you can have constructive and you can have destructive. And we're going to talk about some of the numbers behind this a bit later. But for now, we're just going to look at kind of conceptually how this works. So here's my waves on a string thing. And I'm going to change it to a manual, or to a pulse. Okay? And I'm going to put a fixed end on this. And what's going to happen is if I give it a pulse, by the way, we're also going to see reflection occur. This pulse is going to reflect backwards and kind of move back and forward. Okay, so that's great. But what I want to do is show you a couple different types of superposition or interference. In other words, having two waves in the same place at the same time. So I'm going to hit pulse again, and now I get this weird thing where I have these two waves kind of chasing each other, and sometimes they always seem to cancel out. Okay, so let's take a look at what happens if I go step by step. Okay, so now they're about to interfere with each other. Okay, the amplitudes of the wave on the left are all positive and the ones on the right are all negative, and so when I add them together, they're going to tend to cancel out. You see this one in the middle has 0, and so quickly the wave is going to collapse. And where'd it go? Well, if I were to draw the triangles, one would be kind of like this and the other would be kind of like this. Hopefully that shows up. You can see where the pointer is. But they're pretty much completely canceling out. That's destructive interference. Now, to do constructive interference, I'll do two quick pulses like this. Actually, sorry, that's bad. Let me try that again. I'll do one pulse like that and do another one later. Oh, I fail. Okay. Okay, this is just getting worse. So anyways, you can go to this app and play with it, waves on a string. And actually what I need is a loose end so it doesn't flip. There we go. Alright, and now what you can see is that there's destructive interference, but then also every once in a while there's constructive interference. So for example, they're about to interfere constructively. So you could see that that's just one big triangle, so I'm adding all of the amplitudes. Okay, now one application of interference is noise canceling headphones. Okay, so this is a good way to actually put it to use. What these headphones do is they take in sound from outside and they make the exact opposite waveform. So if there's something that looks kind of sort of like this from the outside, then what they do is they turn it into the opposite, and so when you add it together you get nothing. So that's kind of cool. So that's what they mean by noise canceling. And reflection, we saw a little bit of this, okay? This is when a wave strikes an object. Or it can also strike a boundary with another medium. And we'll be investigating this in our Slinky lab. Okay, refraction is a little bit different. Refraction is a wave changing direction. As it moves from one medium to another. And we'll talk about some examples of this in class. But there's some pretty famous examples of refraction, and the basic idea is that the wave is changing speeds in different mediums. And just to clarify, when I say medium, what I refer to is the material that a wave is traveling through. And so that's very important to keep in mind. Okay, so one thing that I wanted to show you that's kind of cool, there's an app that you can actually get on the App Store, and it's called the Ripple Tank, and there's a free version, and then of course you can pay for it. But the idea is that you can see all sorts of things, like here's waves bouncing off of something. Okay, we have a parabolic mirror over here. So there's all sorts of fun things that you can experiment with. Okay, they also have a paid version, but you can at least get the free one and play with it. Okay, dispersion is when waves of different wavelength move through the same medium. So different wavelength move through the same medium. So the best known example of dispersion that I can show you is a rainbow. So white light enters a prism, and inside of the prism different wavelengths will travel at different speeds. And we haven't quite talked about why that is, but just kind of go with it for now. So because of this, the light spreads out, and that's where we get rainbows from, and also a pretty awesome album cover. Okay, and finally, diffraction is the bending of waves around the edge of an object. And we're going to be playing with this simulation that I'm about to show you. So this is a ripple tank, okay? And the diffraction pattern that you see is when these drops of water reach this opening, they are diffracted or bent around the edge of the opening. And you can see much more of a pattern when you fiddle with the amplitude and frequency. So we'll be talking more about this. Now it's very clear. But we'll be talking about this more and also playing with this in our lab. Okay, and finally, the last thing that we should talk about is the idea of a standing wave. And a standing wave basically is a pattern that arises because reflected waves interfere with more incoming waves. So it's kind of like a jump rope if you think about it. Let me show you another picture that could illustrate this. Let's see. Okay, so here's an example of a standing wave. If you look at it, the blue wave is moving to the right, the green is moving to the left, and if you pretend like the blue wave is bouncing off the right edge and reflecting, then the black, which is the superposition of the blue and green, represents a so-called standing wave. And the neat thing about it is that there are points labeled N, which are called nodes, which don't move anywhere. That's where it's always canceling out. And there's also points labeled AN called antinodes. And these antinodes are where you have the most displacement. So you can see how this kind of looks like a jump rope or a slinky pattern. Okay, so that's about it for this video. Hopefully now you have a better understanding of various wave properties.